now that you know that you can write the equation for a circle, if you know the coordinates of the center are at like x sub c, y sub c, right? And the radius is whatever that is. We can write the equation of any circle, and so we're going to practice writing some circle equations today. Look at them in some different ways. A circle has a diameter with endpoints at 1, -1, and 5, 5. That's the diameter. So I know that the circle is going to go through those points, and the center is going to be in here somewhere. And of course, if that's a diameter, it should go right through the center, and the center should be the midpoint. And you can maybe tell where it is, but let's actually use the midpoint formula here. The midpoint of the x of the midpoint would be 1 plus 5 divided by 2. 6 divided by 2 is 3. And the y of the midpoint would be -1 plus 5 divided by 2, which is 4 divided by 2, which is 2. 3, 2. There it is. So that's the center of the circle. I'll mark it with a C for center. And I also know that, since I know the coordinates of the center are 3, 2, that's going to be part of my equation. The only other thing that I need to write the equation of the circle is figure out what the radius is. And the radius would be this length here. And it's an irrational number, but if I use the distance formula, if I think of that as a right triangle, I can see that it goes up 3 and over 2, right? So let's see here. The radius would be the square root of 3 squared plus 2 squared, which is the square root of 9 plus 4. So the radius is the square root of 13. Now I could get a calculator out and figure out what that equals. It's somewhere between 3 and 4. But let's not do that. Let's just leave it as the square root of 13. It's just easier to work with radical numbers when you're not rounding them off. So if I wanted to actually sketch this circle, I could go up 3 and over 2 this way, go up 2 and over 3, because all those distances would be the same. And then I could get some points that I can connect to make a sketch of the circle. I'm kind of in a hurry, so I did a bad job, but you can see that that's what the circle is. If I need to write the equation, though, now I have enough information because I know the radius is the square root of 13, and I know that the center is at 3, 2. So I go back to this, and it would be x minus the x coordinate of the center. So x minus 3 squared plus y minus the y coordinate of the center, so y minus 2 squared, and that would equal the radius squared, the square root of 13 squared. You know what, though? The square root of 13 squared is 13. So why would I write it like that when I could just write 13? That's the equation of that circle. X minus 3 squared plus y minus 2 squared equals 13. Now let's look at this second one. A circle has its center at 4, -3, and it's called A. And it has a point called B at 6, 1, and it has a point called C at 0, -1 on its circumference. So what is the equation of the circle? Well, if that's on the circumference, then AB and AC should be the same length, and they should be the length of the radius. I already know the coordinates of point A, so that's pretty easy. And I just need to figure out the radius. So the radius, it goes up 4 and over 2. This goes over 4 and up 2. So that is the same distance. So the radius would be the square root of 4 squared plus 2 squared, which would be the square root of 16 plus 4. That means the radius is the square root of 20. Root 20, okay. We're supposed to figure out the equation of the circle. Well, that would be x minus the x coordinate squared, which is 4, plus y minus the y coordinate squared, which is -3, equals the radius squared. And the radius is the square root of 20. And again, just like before, when I square a square root, it cancels that out. And remember that subtracting a negative number, it's just addition. So I could write this a little bit better and write x minus 4 squared plus y plus 3 squared equals 20. That is the equation that defines this circle. And I could find other points on that circle as well. I could go up 2 and over 4. I could go over 4 and down 2 and so on. And I'd get something like this for the circle. But then it also says, what is the area of the sector defined by arc BC? This area here. Leave answers in terms of pi. Okay, so to find the area, I need to know theta. And that would be difficult in a lot of circumstances, but guess what? That's 90 degrees. And you know how I know that? Because the slope of this radius is up 4 and over 2. And the slope of this radius is down 2 and over 4. And you know what those two numbers are? They're negative reciprocals. And negative reciprocals mean that those are perpendicular. So if I wanted to figure out the area of that sector, I would just do 90 over 360 times pi times the radius squared. Okay, so the root 20 squared is 20, and 90 over 360 is 1/4. 1/4 of 20 times pi, 1/4 of 20 is 5. So guess what? The answer is 5 pi. And that's all you have to do. You can just leave it in terms of pi. Have fun with those 3 practice problems.